Okay, so we're going to go ahead and cover maps and hash tables tonight since chapter 14 they basically, Midstate has us blocked from being able to utilize Java. So um, hold on here, it says that they're muted. How did they get muted? There we go. Okay. So, um, so first thing, let's talk about a map. So, think of a map as something we are going to. We're going to take a trip across country. So, what we're going to do is we are going to go from town to town to town to town. So, kind of what they're showing here is basically we're going to be talking about data. I need to go from this data to that data to that data. And in each little town is going to have a certain key. Think of it as kind of a unique identifier for that particular town. So in this particular case, we're going to use the town name as the identifier. That's going to be our key. Um, so, so with our map, we're going to have different methods available to us. And again, methods are those, I call those the verbs of Java. We've got one that's called size, we've got another one called is empty, we've got another one called get. It gets something, returns it. Put means go ahead and write something to that. Add this particular piece to that. So put this in something. I can remove something. I can actually say, hey, let's take that out. I got a key set where I can actually then modify the keys. The value is no, it's popped up. Okay. Key values are the actual data inside of each one of those items, and then we have an entry set. So we can actually then add something to the map itself. Okay, so I know that's kind of complex there. So here's kind of the Java code that we have. So for here we have a for each, and so it says basically we're going to have a p, which is a variable, and well, let's skip that for just for now. So hold on. So, getting back to maps, so here we have something called an ordered map. Okay, so we've got so we have more methods. We've got first entry, last entry, ceiling entry, floor entry, lower entry, and higher entry. We'll get more detail at each one of those. So with an ordered map, we have to implement it, basically create it. And so what we're going to do is we're going to have these, think of it kind of like an array. And it's basically, it's right here says the map is basically an ordered table. So we only show keys for this map so as to highlight their ordering. Let's see if they give us a better example here. This book is really complex, and I don't want to get too over your head. So, okay, so let's say, in this particular case, we're going to do a search. So we've got this table that's got data in it. And so what we have is, don't worry about the data inside of those are the values. What we're more worried about is each box. So the low is basically the first box, and the high is basically the box at the other end. And then we have what's called mid, okay? So we're going to do this thing called a binary search. So the very first thing we do is we make sure everything has to be in sorted order. So that's the very first thing that we basically have to do in this particular case. So it really doesn't talk about it here. I think it talked about in the previous one. we got to make sure everything's sorted, so we sort it. So the very first thing we do, so it's a binary search. Binary means basically a 1 or a 0, so it's basically true or false. So in this particular case, we take this table and we cut it in half. And where do we cut it in half? We cut it in half at the midpoint. So we're looking for the number 22. So the very first thing we do is we cut it in half. And we've got this half and we have this half. And we say, is 22 in this half? It's not. Then we go ahead and grab this. So if we look at the second block there, we're going to start here. So now we move the low to this block. The high stays where it's at. And then we put the mid right smack dab in the middle again. So then we say, and these numbers here, all the way up to the mid, is 22 here or is it here? Okay, it's here. Then we go ahead and block those off. And we then move the low, keep the low at 17, but we move the high to the 22. Okay? And we put the mid right smack dab in the middle. And we say, is the 22 here on this side or is it on this side? It's on this side, and then basically we have found it. Okay? So what we do is we take a table, we cut it in half, then we cut it in half again, we keep cutting it in half, keep cutting it in half, and we keep saying, is the number we're looking for in this half or in this half? Oh, it's down here. Then we basically get rid of that half and we just concentrate on this half. And we can basically, so there is a formula to this, a mathematical formula that says we can only cut this table in half so many times before we actually find this item. And so that's basically what happens, is we keep cutting it in half. In this case, we found it in 4 moves. Now if this was a huge table, let's say it had 10,000 records in it, we can find those items, okay? So that's basically a binary search. Let me see if I can draw it out a little better. So I've got this box, and let's just say it's filled with a bunch of numbers. Well, the very first thing I do is I cut that box in half. And I say, is the number I'm looking for up here or is it down here? Oh, it's down here. Then I basically drop that off. And now I take this box and I cut it in half. I'm looking for the numbers. Is the number here or is it here? Oh, it's up here. Then I basically forget that half of the box. And I cut that guy in half. I'm looking here or I'm looking here. Oh, it's here. Then again, I drop that one off. Now I'm just looking in this group of numbers. I cut it in half. I look here or here. Oh, it's here. I block that one off and I cut this guy in half. Is it here, here? It's not here. And then I basically drill down until I find it. And again, it's very, very important that this is sorted first. We can't do anything because if it's not sorted, I can't cut it in half and go, are you here or here? Because the numbers aren't in any type of an order. So again, it's very, very important that it's sorted first, and then we basically start cutting that table in half. And the only way we can do that is via a map, and a map is it's a property in Java that allows us to use a map. So I'm not even going to go into this equation here because I'm going to lose half of you. So here's some of the things we can do. We can say, we can get the size of the map. We can check see if the map is empty. We can basically then put things into the map. We can get things from the map. We can put things into a specific part of the map, and we can remove. So a map is really just like an array, except it's a little more robust. It's got a little more features, a little more things that we can do with it. So there are several websites on the internet that allow us to use and perform queries on flight databases to find flights between 2 cities, typically the intent to buy a ticket. To make a query, a user must specify the origin and destination cities, the departure date, and departure time. And then to support such queries, we can model the flight database map. Okay, so here's the situation. We got ORD, which I believe is Chicago, and PBD. I don't know what PBD is. But it looks like we're going from Chicago to PBD on May 5th, And here's the 4 different times we're going to basically go. Then coming back, I'm sorry. So these are 4 flights. And it looks like it's American Airlines. Here's the different flight numbers, and here's all the different details for each of those flights and the cost. So now we need to find out is what's going to fit our schedule as opposed to cost, time, so on and so forth. So they're talking about life is full of trade-offs. We often trade off a desired performance measure against a corresponding cost. Okay, so are we looking for speed? Are we looking for cost? So those are kind of the different things we have to kind of look at. For example, if you're traveling in a car, are you more worried about getting there in the fastest amount of time, or are you worried about basically using the least amount of miles? So for example, is I can maybe take 2 lanes to get from point A to point B because it's more of a straight shot and it may be less miles. But if I get on the interstate where I can go 70 miles an hour as opposed to 55, I can get there faster even though it's longer. So those are kind of the trade-offs that we have to kind of look at, and that's kind of what they're saying here is, you know, in the particular flights is when do you want to get there, when do you, how much money do you want to save, so on and so forth. So maybe early morning when most people want to travel to get there and have a day of being at their destination, that's when a lot of people travel. That's when there's more demand, which means the cost is higher. But if we leave later in the day, the costs get cheaper, but again, now we're basically getting there at the end of the day and we just don't have the time to spend at our destination at that time. So here's what I got, performance and cost, and so we have to kind of pick the ones that kind of fit in our, maybe we find something around noontime and it's a 3-hour flight, we get there at 3 o'clock, we still have a better part of the day to spend at our destination and we save a little bit of money, okay? Or maybe I don't mind spending the money and I want to get there and spend as much time as I can because I only have 3 days of vacation, so I want to utilize as much as I possibly can to basically enjoy my destination. So that's kind of what they're basically showing in this particular item. So I wish I had a better example for maps. Let's try this. So let's see what this particular person is doing. So here we have public static void main. We've got our map vehicles equals a new hash map. We'll talk about hash maps in a second, but it's a map. So again, think of a map as like it's basically an array. So we kind of treat it the same way. So in this case, we're going to add some vehicles. So I say vehicles.put, here's BMW, comma 5. Now what is the 5? The 5 is the key. So I'm assigning a number 5 to this particular entry into my array. Mercedes, I'm going to put a Mercedes in there. I'm going to give it a key of a 3. Audi is a 4 with number 4. Ford is a 10. So I basically put those 4 items into my map. And then I can say total vehicles, vehicles.size. So what is vehicles? Vehicles is a map, but it's a hashed map data type. We can say .size and we return the number of entries into that map. So it will return the number 4. Then I can say for string key. What is key? Key is going to be a string variable, and we are going to say vehicles.keySet. And so system out print key vehicles get key. So in this case, this is going to go through and so the key is a string. So then again, it's just a variable name. Don't think it's anything special. It's just a word we chose. This could say string stuff, and it's going to get the same exact result. So we're calling it key because we're worried about getting these items out of each one of these entries into the map. And so I say key set. So it basically is grabbing the key set of each entry and throwing it into key. Next time we go through this loop, it grabs the next key set, which is the next key, and throws in this variable key. So right here it's going to say key dash vehicles.get key, and it's going to then put that into this variable called key and basically print it. Then we are going to click string search key Audi. So basically create a string called search key. We're going to make it equal to Audi. And then I say if the vehicles dot contains key, search key, then we will say it's been found. So this is kind of cool. So this contains key is kind of a search. It's going through that map and it's basically looking for this item called Audi. So this is found total vehicles dot get search key. So again, I could have multiple Audis in here, but the only thing I can't duplicate is this key. This key cannot be duplicated. These guys can be duplicated, but the key cannot. Okay? So if you kind of think of employees in a business, we could put employees in there, and their key could be their employee number, because we don't ever want to duplicate an employee number, because that's how we pay our employees. Could I have two Tom Smiths? I most certainly could. So I could have two Tom Smiths, but they're going to have different employee numbers. So in this case, it's going to return the key, well, the search key in this case, which is the actual Audi, the name of the car, and it's going to basically show that it got found. Okay. So if vehicles.contains search key, then basically print found total vehicles.get search. So it's going to return the total number of vehicles that have an Audi in its value. And I say vehicles.clear, which basically clears all the values. That basically empties everything out, right? So when I get through with this line, guess what happens? Our map is empty. Well, I shouldn't say that. I believe it still has the, it still has these keys in there, but these values are gone. And then it says after clear operation size, or does it? Now let's try it. Let's see if it works. Way to grab so let's just see what it will give us in this hash map. So let me create a new project. We'll call this mapping. And we'll create a new, what do they call it? I believe they call it hash map example. So here we have it. So let's go ahead and click save, and let's click submit. Oh, so it doesn't like something here. Let's see what it says here. It says not convert element type object to string. Ooh. So let's try this. Did that get us past it? Let's see. So we got Audi 4, Ford 10, BMW 5, Mercedes 3. So that's basically what it did in this first loop, is it printed those out. And then it found total 4 Audi cars. That must be a number. That number of, it's kind of a key, kind of a value. So it's basically saying it found 4 of those. So that's kind of our unique number, and basically our key as well. So it basically returns, says it found 4 Audi cars after the operation of the site. So apparently I was wrong. When we click this guy right here, it totally wipes out that map. So basically that entire map is basically gone at this point. So again, so kind of a difference between an array and a map is we've got a couple of values in there. We've got a key and we've got our value that we can basically store within that map. And another thing too is with an array we have to give it an index. We have to give it an index number. With hash maps and maps, we don't have to. We can just use that table as is. So if you remember, an array list is different than array because we can just utilize it and add to it, so that sort of thing. Well, same thing with a map. We can actually add elements to the map. We can get elements from the map. Okay. Let's see if they have any other examples. That's a pretty good example. So before we kind of continue here, realize that a map is part of a bigger picture. There's a bigger, broader picture of a thing called a collection. And a collection has a whole lot of stuff underneath of it. It's got maps and trees and hash maps and all kinds of different array type groupings inside of it. So yeah, hash map, hash table, enum map, hash map, linked hash map, properties, tree map, and a weak hash map. So those are all a lot of different things that we can utilize with the map. So generic maps, by default, you can put any object into a map. So in this case, we said for string key map.key set. So we're going to go through this map one key at a time. We're going to grab this key and throw it into this key. And then we're going to say my object value. So it's basically just an object. So apparently we have a my object up here, which is a map. And we're going to say map.key set. I'm sorry, get the key and put it into that value. Okay. So a little more, a little more powerful than an array. Different types of collections. At this point, you probably are going to be more familiar and more comfortable with an array list than you would a map. So, let's see. So the map interface maps unique keys to values. So again, I talked about the unique key, which we're going to, so with an array we have an index, and that's just automatically set because you know, again, kind of the example I like to use is we have a bookcase. So my bookcase is going to be that item, so it's a big square bookcase, and we create a data type. We say we're only going to put string data in there, we're going to put integer data, whatever the case may be. Then I go ahead and then tell it how many shelves I'm going to have. And once I set the number of shelves, I can't change the number of shelves. Well, with a map interface, we are going to basically say, I've got this map, and each item I put in there, I'm going to put in a unique key value that goes with that value. Okay? So this key kind of gets set. So again, talking about employees and the employee number. After the value is stored, you can retrieve it by using its key. So I can actually say, retrieve that employee with this employee number and bring it back. Or I can actually do a search for an employee name and then bring back the keys. Several methods throw a no such element exception when it doesn't exist. A class cast exception is thrown when an object is complete with the elements. So basically, again, a no cast exception meaning I'm trying to retrieve a integer data type and I'm trying to cast it as a string data type. So I'm trying to basically utilize it as a string when it's not a string. Null pointer exception when there's no value in that particular map. Okay. Unsupported operation when it's made to change. So basically, if we have an unmodifiable map, there's a way to turn a map and make it read only. If I try to modify it, I will get this unsupported operation exception. So here's some of the different methods. Clear, we know what that does. That clearly clears out the map. Boolean contains key. I can say, does it contain this key? And it will return true or false. Contains a value, same thing. Does that map contain this value? It's going to return true or false. So a entry set that returns a set that contains the entries of a map. The set contains the object of type. So basically, it's going to return a map type back. Equals. So if we are looking for so if we're going through the map one element at a time, I can say, does it equal this? And again, it's going to return a true or a false. Get something, it's going to get something and put it into an object data type. Hash code. Hash codes are kind of, they're everywhere. So each object that gets created, I always call it the social security number. Each object that gets created gets a social security number set to it. So just like an employee, when I have employees, each employee has a unique social security number. Well, every object gets a unique code set to it. It's called a hash code. In this case, a map will have a hash code because a map is an object. And each item inside of there is an object, and each one of those has a hash code as well. We can check to see if something is empty. It will return true or false. Set key set returns a set that contains the keys invoking a map. This method provides a set view of the keys, and so I can actually see the keys that get set for those particular values. Object put, again, I can put stuff into the map. I can put all. It puts all the entries from something, in this case M, which is also a map value. So I can actually take one map and put it into another map. I can remove an item, I can get the size, and then I can actually say, hey, give me all the values and put it into a collection. Again, a collection is array-like. Think of it like that. So map has implementation in various classes like hash map. Following is an example of a map functionality. So here we basically have map m1 equals new hash map, m1.put. Here's the value, here's the key, value key, value key, value key, and then basically I can then print all the elements by saying print that map. It'll print all the elements. And it was says, so it would print the word map elements, and then it would do a tab, and then print all of the maps, and it would basically print the open brace, the ending brace, and it would say ma_naz equals 31. So there's that. AN equals 12, days equals 14, 0 equals 8. So again, it would show the value and then its key. So then this, in the data structures, it talks about hash tables, and it says one of the most efficient ways to implement a map is to use a hash table. Although you'll see the worst case running time of a map operation, that's very good. Okay, so let's this book is terrible. Let's go to hash table and see what they have. So hash table is part of the original Java util, and basically it's been around a long time. So it's like a hash map. Hash tables store key value pairs in a hash table. When using a hash table, you specify an object that is used as a key, and the value that you want linked to that key. The key is then hashed, and the resulting hash code is used as the index. So basically the difference here is we use the hashtag as the index. So we got a lot of the different same methods. We have this new one called clone, which duplicates an existing element within that hash table. We got a contains key, contains value. We can use enumerators, and again, that's a whole nother chapter in the book. We can get objects. We can check to see if they're empty, and we have the enumeration keys. We also can put things into that. We also have this thing called rehash, and it basically says increases the size of the hash table and then rehashes all the keys. So what it says is, I need to expand this table bigger, and let's go ahead and get all new keys for those new items we're basically putting in. I can remove, I can get the size, and I do have a toString as well. So here we have our hash table demo. So let me grab this. So I've got a hash table. It's called balance, and it's a new hash table. So a hash table is a data type, just like string and all that. But it is it's a class object, so it has its all set of methods and instance variables, so on and so forth. I've got an enumeration. I'm going to call it names. I've got a string, and I've got a double. So I say balance, which is my hash table, dot put 0, and I got a new double. So I'm creating a new instance of a double data type, and again I'm using the capital letter D double, and I'm going to put that number into it. That number, that number, that number. So that's going to be our key attached to each one of those variables. Names dot balance keys. So all the balances in the hash table. So now we've got all of those keys basically in the names data type, names variable. While names dot has more elements, meaning we're going to go through names one element at a time while it's still. So we're at number 1 right now, and it's looking at the next hash table element. If one exists, it's going to keep doing this while loop. So I say string equals string, so we're converting whatever it is, we're casting it to a string. Names.get next element. So it grabs the first element, throws it into str. Then it prints str colon balance.get string. So then it basically gets the key from whatever. So again, if the first time through, if it finds Alan, it's going to print Alan right here, and then it's going to print So the balance.get, so balance is going to get the string variable, it's going to grab the double, okay? Which it happens to be 1378.00. Then it says bow, what is bow? Is equal to, where's, I don't see where bow is. Oh, there it is, right there. There's where bow is, so it's a double. Is equal to, so it casts it as a double. It says balance.get Zara.double value, so it basically, so double value is a method, and it basically gets that, so balance.get Zara, so it's going to, so double value is part of a hash table, and .get is also part of that hash table as well, so it's basically saying, hey, grab the double value of this particular key that has Zara in it. So it goes to Zara, and it's going to bring back 3,434.34. Then it says put Zara.newDouble, so it's instantiating a new value of bow dot plus 1,000. So it basically grabs, so it gets the balance from Zara, and it's going to add 1,000 to it and put it back into that hash table. Okay. Let's take a break right here. I think we've done stopped. So let's take a quick break and we'll come back in just a few minutes.